You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone. My name is Bob Keane. Thanks for tuning in to Fire Ecology Chats. I really appreciate your time. We're going to talk about an incredibly great paper today that was published in Fire Ecology. And for those of you who don't know, Fire Ecology is an internationally renowned journal that is published by Springer Nature and is overseen by the Association for Fire Ecology. Today, we have two wonderful people here to talk about this paper, Wildfire Management Decisions Outweigh Mechanical Treatment as the Keystone to Forest Landscape Adaptation. We have Tucker Furniss and Zhuoran Duan here. Tucker, do you want to introduce yourself?
Sure. Thanks, Bob. My name is Tucker Furniss. I'm an assistant professor in the Department of Ecosystem Science and Management at the University of Wyoming.
And Zhuoran, why don't you introduce yourself?
Thanks, Bob. Hi, everyone. I'm Zhuoran Duan. I'm an earth scientist at Pacific Northwest National Lab.
Well, welcome the two of you. I really appreciate your time to talk about this wonderful paper. It is not often that I get to talk to a fellow modeler, Tucker. I know you use LANDIS in this one, and it made me very excited to read it. And so I'm very excited to hear about the paper. Can you tell us a little about the paper and give us the elevator speech?
Sure. So this was a simulation modeling paper. We used LANDIS to simulate the interactive effects of future climate and land management, thinning and prescribed fire and wildfire regimes on a large forest landscape in central Washington state. So we simulated several different management scenarios with or without thinning, with or without prescribed fire, and various levels of wildfire use. And we compared the outcomes of these different management scenarios over the next 100 years on a bunch of different metrics of forest ecosystem structure and composition and function. The real take-home message from this study was that wildfire really runs the show. The management scenarios were all different, but they were subtly different, and they were different primarily because of how different management scenarios were mediating future wildfire regimes. So the direct effects of management alone were minimal. The indirect effects of management on wildfire regimes were really driving the results.
I think that's incredibly important. And, most modelers, they forget to add wildfire into the model. And when it turns out that it's the most important disturbance element, it really drives things on the landscape scale. Are there any other results that you think are important from this incredibly diverse modeling effort?
There was an inflection point in area burned under some of these management scenarios, but not all of the scenarios. This inflection point was really interesting. We dug into it, and what we were interpreting was we were seeing the potential for feedbacks between fire and fuels, where one fire could increase the probability of a subsequent fire, and we were seeing how this could destabilize a future fire regime, potentially driving type conversion. And it was just really interesting how we were seeing that in some of our scenarios and not others. So it was indicating to us that it was not something intrinsic to our modeling approach or to future climate. It really had to do with the structure of fuels and forests on the landscape. So another result was that mechanical fuel reduction treatments did not prevent this feedback. One of the key characteristics of the study area was that it was over half wilderness and roadless areas. So our treatments were limited, as they are in real life, to areas in the WUI, areas in actively managed forests. And the important thing there was we found that in the way that we were simulating these treatments and the way that wildfire was being simulated, the treatments alone were not enough to really change the future fire regime. Interestingly, the wild and fire use scenarios where we simulated different timing and levels of suppression being applied sort of differently to simulate what wild and fire use practices could look like in a plausible future scenario. So those scenarios actually resulted in the greatest reduction to high severity area burned and a more linear trend, a more stable trend in future area burned. So that to us really emphasized the importance of wildfire management decisions, when to suppress, how hard to suppress, where to suppress. So those wildfire management decisions were really the key thing driving future landscape dynamics and future wildfire regimes.
Wow, that's amazing. These diverse results can be all packaged up. What do you think would be the implications to management, Tucker?
To me, the study really does not tell us anything that we in the fire ecology community don't know. From a number of studies and reviews and perspective pieces, it's pretty well established. This is another look at it. This adds more evidence to the pile that underscoring the point that we really need to think seriously about evolving our relationship with wildfire. One of the new things that this paper added is fuel reduction alone is not the solution. That's not a silver bullet. There's, importantly, one of the barriers to wild and fire use is a public distaste for smoke, lack of funding, general social license and sort of understanding for wildfire management practices done well or done poorly. So I think one of the things that this paper shows is we really need to start seriously thinking about that wild and fire use piece of the puzzle. And that should be front and center in our thinking about adapting to a novel future with more wildfire.
When I read the paper, I was amazed that it turns out that hydrology plays an incredible role in this whole modeling effort. Zhuoran, do you want to talk about the role that hydrology plays in your simulation?
Sure, I'm glad you pointed that out. I think integrating hydrology into forest management decision-making are essential as the forest management influence the water dynamics and therefore influencing the ecosystem service hydrology has. When we think of forest management can potentially alter the flow regimes as well as the snowpack regime. It could potentially alter the magnitude and the timing that the stream flow has. The timing of the stream flow are important because they could alter, say, the salmon habitat if they can provide sufficient low flow in the summer for salmon habitat, as well as if we have a decrease or increase stream flow magnitude, that could impact our hydropower potential as well. Like in places where flood peaks are of concern, the altered forest could potentially impact the flood peaks as well. So it's very important to consider hydrology in terms of forest management.
I noticed that there were a lot of links to other efforts or related work that went along with hydrology. Do you want to talk about that?
Yeah, there's another paper that we are preparing in terms of with a more focus on the hydrology component. Tucker is leading this effort. In this paper, we have more emphasis forest management interactions with hydrology. We noticed that resinning treatments contribute to modest increase of annual flows, although effects were overwhelmed by climate and wildfire. Wildfire is definitely dominant driver in terms of a lot of changes, but also under climate change, the warming climate has overall more influence in terms like a driver of the stream flow as well as snowpack compared to the forest management and the wildfire effects.
Well, I surely want to thank both of you for coming on and talking about your paper today. It's a wonderful paper. It's an incredibly interesting paper, and it's a paper that ties a lot of things together. Tucker, would you like to recognize any of your co-authors or funding agencies?
Yes, definitely. And we also want to thank you, Bob, for having us on and for doing this podcast. It's a pleasure to be a part of it. So our funding for this was provided by the U.S. Department of Energy Bioenergy Technologies Office and the Forest Service Pacific Northwest Research Station. And the co-authors on this paper were myself and Zhuoran, as well as Paul Hesberg, Nick Kovac, Brian Salter, and Mark Wigmasta.
Okay, thank you both for coming and giving your time today. For those of you who find this paper, the title of which Wildfire Management Decisions Outweigh Mechanical Treatment as a Keystone to Forest Landscape Adaptation, if this paper is interesting to you, you can go to our Fire Ecology Journal website that Springer maintains and download it for free. You don't have to pay for a darn thing. You don't even need to get a subscription. Tucker and his group have already paid the freight. Go ahead and download this, so please download it for free and read all about this wonderful study. And with that, I'd like to invite you back to the next Fire Ecology Chat.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. fireecology.org.